Hello everyone, I'm Samantha Laureano,
And I'm Ben Salerno.
and we're students at the Bergen County Academies.
So, MIT and NASA have joined together to find solutions to the problems they face in sending humans to colonize Mars. They sent out requests to our school, among many others, to offer assistance in solving the issues in sending humans to Mars. We chose to assess the problem of getting these astronauts to Mars in a shuttle with a closed-loop, reliable life support system that will be able to get them to Mars and back home to Earth safely. We found out that the trip will last approximately 8 months under optimal conditions when Mars's orbit is closest to Earth, and our findings and solutions are based off this. The general problems we faced were limited supply of food, limited supply of water, limited supply of oxygen, and no gravity. We plan to solve these through extensive research, including scientific studies and articles and papers published by NASA about their existing accomplishments, because if it's not broken, there's no need to fix it. So we'll be using some of the machinery, intelligence, and concepts that NASA has already tested and shown their effectiveness of.
Hopefully we'll be able to improve upon what NASA has already accomplished, and open up the frontier for what may possibly be our new world, Mars. So now that you've seen a quick slideshow of pictures of our space garden while it's being built, let me explain it to you. This is the main focus of our proposed solution, and is explained later on in the video, and even further on the website we created just for this project, which is in the description. So this as a whole represents a chamber separate from the living quarters on the shuttle, which we will utilize for maximum growth potential of the plants. Now inside, you see two reliable and efficient systems of growing plants in space. Hydroponics on the bottom with a greenhouse effect, and aeroponics along the walls. NASA in the past has put these systems to work in the living quarters itself, but it only grew about 20 plants. This garden will be able to support hundreds of plants, which will provide a major source of oxygen for the humans, as we plan on pumping out the oxygen produced by the plants through this tube, which are on the ceiling. And in return, the carbon dioxide that is a byproduct of respiration from the humans' living quarters will be pumped back into the space garden through this tube, creating a cycle of these gases to keep both humans and the plants alive. And of course, these plants will need a light source to start the process of photosynthesis. The sun isn't exactly a reliable source for the astronauts, as it depends on which direction the shuttle is traveling in, and being that we're going towards Mars away from the sun, it's probably not going to get to these plants. So instead, we decided to substitute these artificial lamps, which are shown by these yellow circles, for sunlight. And lastly, the whole point of these two systems are to allow the plants to grow without soil, but rather with mineral-enriched water. So for the aeroponic plants, this water will be coming out of these sprinklers, as shown by the black little balls of clay on the bottom to reach, and as these sprinklers will shoot up, the water will be able to reach their roots. Now the water reservoir, denoted by the blue clay below the hydroponic plants, will be the water source for the hydroponic plants to grow in. So now that you've seen the entire progression of our project, it's time for the finale, our final proposal. We've realized that in order to keep the astronauts in good health, we ultimately need to create artificial gravity. NASA has already successfully accomplished this, as seen at the International Space Station, in which a ring-like structure rotates around the space station, creating centripetal force. As a counter-reaction to the centripetal force, centrifugal force acts back upon it, creating the artificial gravity. This negates the muscle atrophy, among other occurrences that affect the astronauts when they return to Earth after being in an environment that lacks gravity for so long. We've also realized that energy is a major resource we need, and as NASA has already accomplished this as well, we've decided to include solar panels in the construction of our shuttle. These solar panels will be on the bottom half of the shuttle, as we are traveling away from the sun, so the sunlight will be highly concentrated on that side. Now, along with these solar panels, above them we will have heat regulation panels that will normalize the temperature inside the shuttle, to about 70 degrees Fahrenheit. These panels will expel the heat into outer space when too much is produced from the machinery working inside the shuttle. Now, moving on to the interior of the shuttle. We've already discussed our major addition to the space garden. Besides just an oxygen source and recycler, these plants will also be the main source of calories for the astronauts to survive. We've concluded that each astronaut needs about 800 calories per day, and even less when they're under sedatives. These sedatives will be used to keep their physical activity low, so their natural body processes will stop, using less energy, and thus needing a smaller supply of nutrients and calories. Still, they will need to eat, so we've decided to grow plants such as beans, soy, and peas, which are high in calories per serving, but are also nutrient-dense, which will in the end benefit the astronauts. For the entire trip, which will take about 8 months under optimal conditions, each person will need about 195,000 calories. It doesn't stop there, however. These plants still have more to offer. We will be growing leafy plants such as lettuce, which retain large amounts of water, which will still benefit the astronauts even further. And there's still more. As we talked about earlier, the plants will be providing the main source of oxygen for the astronauts. The liquid resources that NASA uses today will still be on board as backup in case something goes wrong. It takes about 350 average-sized plants per person to produce enough oxygen for them. Each person will breathe in about 7 to 8 liters of oxygen per minute, which means about 11,000 liters a day. The large capacity of our space garden will surely be able to support this many plants. So now that we've talked about food, we have to consider the inevitable wastes. And don't worry, we're recycling that too. NASA already has toilets that use complex systems to bring the waste to a chamber below, where the liquids and solids are separated. The liquid is sent through a water purification system, where about 93% of the water is recycled. This can either be used to replenish the astronauts, feed the plants, or be split into oxygen and hydrogen molecules, of which the oxygen can always be used. Now on to the solid matter. NASA is building new machinery that will burn the solids for their hidden nutrients, which we plan on utilizing. After incineration, the most important things left are nitrates, salts, and potassium. These can be put back into the rich water supply in the space garden, as these are some of the nutrients needed in the water as we are no longer using soil. So now that we see that water can be recycled from our waste, but an extra supply of water is still needed. 93% of the water is recycled, but that still means 7% is lost. Over time, this can really add up to a large amount of water loss that we cannot afford to put the astronauts' lives at risk for. Each person needs about 350 liters of water for the entire trip. Being that most of it can come from the recycled water, we'll assume that we'll only have to carry an extra 100 liters per person. In conclusion, we've negated the need for both soil and large amounts of dried space food that NASA is famous for, and we've cut down the amount of water needed to be brought along. Each pound of supplies being brought into space costs about $10,000, which can really add up. Hopefully, we've cut down spending greatly, and we've created a successful life support system for these astronauts to survive in on their mission to Mars.
As Obama said on April 15, 2010, by the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth, and a landing on Mars will follow. I expect to be around to see it. And so do we. Thank you.